this video is all about wireless systems. So in this video I tried to give you an overview about what should you consider, or what should you pay attention to when you use wireless systems. I don't give you a very like deep insight into how the systems work, and I don't basically give expert knowledge here. I just give some basic knowledge just so that you can use the microphones. So first thing here is an overview about how I would set up a wireless microphone system. So first thing, you always have to be aware of how many wireless microphones do you have. So if you just have a few, let's say 4 or 5, then you don't need like big complicated systems. You can just use the receiver, the microphone receivers, and the antennas delivered with the receivers. That's okay. But if you have like many microphones, more than 5 let's say, you will suddenly get lots of different receivers and lots of antennas, and then there will be higher likelihood that you have interference on the wireless like on the wireless signals. So what you should do then is you should basically just use 2 antennas and use an antenna splitter to connect all the wireless signals to the receivers. And this is what this image shows here. So we have microphones, and I basically show the signal flow here starting from the microphone. We have microphones, and these microphones send signals to the antennas. So we do normally do 2 antennas, not just one. The reason therefore is that there can be like frequency gaps in space, let's say. So sometimes it can happen that the microphone is at a position where the frequency cannot be transmitted to that one antenna. So we normally do a second antenna so that basically the whole room, the whole area is covered. So it's not, I mean, it's also kind of a redundancy thing, but the most important thing is to really also cover all the frequency holes. So I normally also do like set up the antennas in a little bit of an angle. Maybe I can take this in a quick drawing. So normally I put the antennas on a microphone stand, but then I do an angle on the microphone stand. So here we have the antenna like pointing into some direction. So I normally do it in an angle, so I don't do it straight, and then I use a second antenna. I use a second microphone stand and also do it, I also set it up in an angle. To be honest, I'm not 100% sure what the advantage is when we use the angle. It was just it should be better so that the frequency range, like the room is covered better, that the pickup is working better. I think also the microphone people don't like hold it in an angle normally, so this reflects the angle of the antennas too. But this now would go very deep into this wireless systems theory, which I don't cover here. But that's how I normally do the setup of microphone wireless antennas. So we got these 2 antennas. They pick up, both of them pick up the signal, and then they basically are connected to an antenna splitter. So what does the antenna splitter do? It basically got 2 ports, port A and port B for the 2 antennas, and then it got lots of output ports which you can connect to the receivers of the microphones. So each receiver normally depends on the receiver a little bit, but I think they normally also have 2 ports, input 1 and input A and input B, so that you can connect both of the antennas. So from the splitter you will go to the receivers, once with A, once with line A for antenna 1, and once with line B for antenna 2. So you basically go to all of these receivers with B and C cables, and then from the receivers you basically pick up the signals with an XLR cable and send it to the mixing console. So that's the whole signal flow for wireless systems. So now the big question arises that if you have like these big wireless systems, many microphones, probably you even use in-ear, like wireless in-ear monitoring systems, so you got even more signals. You can easily get up to 20 wireless signals. So you somehow have to arrange these signals within the frequency space. Every microphone you have to assign a specific frequency, and so you have to basically do frequency coordination. So the first thing is you have to find out in your country which is the frequency range you should use for microphones or for wireless systems for events. So try to find out in your country that they can change from country to country. So try to find out in your country which range do you have to use, and then try to distribute the microphones within that range. So there is different software available on the market which basically does this frequency coordination for you, because there is certain gaps between frequencies, like between microphones, frequencies you set, which are like working either better or worse. So these frequency coordination softwares, they help you to get this done better. The one I was using is called Wireless Workbench. It's the coordination frequency from Shure. So I have mostly been using Shure mics, so that software helped me a lot to do that coordination. Of course, you can also find other tools online which can do a similar job for you. So last, I would like to talk about a few typical application errors which I have often seen when it comes to wireless systems. So whenever you experience problems like dropouts in the signals or something else, I want to encourage you to think about this list and think about what could be the issue there. So issue number one maybe is like blocked signals, that the antenna is basically not having a direct connection to the microphone. So try to make sure like the antenna can point to the microphone directly, and that all the equipment, all the cables, everything you use is proper equipment, that basically there is no way for the signal to get cut off at any point. Also, the antenna type, there is very cheap antennas available, so make sure you get a good quality antenna and that you position it such that it can reach the microphones in a good way, as I also drew for you before. So make sure you can put the antennas at the height of the microphones, basically like at the height where the people like 1.5 meters, probably 2 meters, and put them to the side of the stage so that they point on the stage to get the best connection, like the best connection or for all the mics on the stage. So that's number two. Make sure you get the right antenna and position it good. Number three, not well-defined frequency coordination. So often people just pick frequencies, and if it works, they go with it. So try to really do the frequency coordination properly. Use the software so that they will do a good job for you to pick the right frequencies. And then number four, this happens too often also, that the battery management doesn't work. We always need batteries for these mics, and so often batteries run empty, and the signal is cut because of an empty battery. So make sure you think about how you can make sure the batteries are always full. And then last one, number five, not enough gain. So as mentioned, also in the microphone section, wireless mics do have often, especially condenser mics also, do often have an additional gain you can set in the mic itself. Depending on the strength of the vocal, like of the voice of the person singing or speaking, you can change this gain. So it could be that the gain is too low, so you don't get enough signal. So also always consider that, to have the microphone gain at a good position. So yeah, that's basically it. That was the last video of unit number 2. So we covered now lots of different topics. We talked about microphones, we talked about how to place microphones, especially on drums. We talked about different speaker types, about why we should use DI boxes. We talked about different types of wires, and now in this video we talked about wireless systems. So this basically covers our electroacoustics unit, and we will now continue with unit number 3, which is signal processing.